Hi, I'm JJ Sawicki from TRC. Welcome to our Heat Pump Boss series, Level Up Your Heat Pump Installs. We've got the tools, tips, and how-tos that will help make you an expert heat pump installer. Today we're going to focus on overzoning. Let's dive right in. In this video, we'll explore key considerations for heat pump design and zoning. We'll discuss the difference between zonal and whole home systems, how to select and size heat pumps for multi-zone designs, and the impact of overzoning on system performance. You'll also see real-world examples that highlight the importance of thoughtful zoning and proper equipment sizing. Let's dive in. When designing a heat pump system, it's important to consider whether the home will be split into zones or treated as a whole home system. In a zonal design, the home is divided into multiple zones, each with its own thermostat and control. This approach is ideal for larger homes or homes with complicated layouts, as it allows for precise temperature control in different areas of the house. On the other hand, a whole home system uses a single thermostat to control the temperature throughout the entire home. This design works best for smaller homes with simple geometry and is often paired with ducted systems for even air distribution. The choice between zonal and whole home design can also depend on homeowners' comfort preference. Taking the time to evaluate these factors will help you create a system that's both efficient and tailored to the customer's needs. Zoning with heat pumps is so much easier than it is for other system types that we can avoid the challenges and costs of whole home distribution common to central furnaces and boilers. The most obvious zoning is to separate each floor as its own zone and remove the effort to blow air or pump water between floors. Homes with an isolated wing or an above garage apartment are ideal to set up as their own zone, and you can avoid the long extended duct runs otherwise needed. Master bedrooms are a great space to give their own compressor and ductless head, giving the customers ultimate control over their sleeping temperature. When it comes to zonal systems, there are several options to choose from, and each has its own strength depending on the home's layout and needs. Ductless systems are a popular choice, with heads in each zone that have their own controls. These systems can be designed with multiple compressors, multi-splits, or branch box setups, giving you flexibility in how you distribute heating and cooling. Ducted systems with zonal dampers and controls are another option, but they tend to be more expensive and can be tricky to work with. Some installers find them buggy with higher rates of callbacks. If you're confident in zonal design and installation, these can work, but if not, it may be better to avoid this approach. A more functional option is a ducted system with separate air handlers, ducts, and indoor units for each zone. This setup uses multiple compressors and is something you almost never do with a fossil fuel system. But with heat pumps, it's a viable and an effective solution. And then there's the mix and match approach, which lets you get creative with your distribution design. For example, you could use ductless heads downstairs and a compact low static pressure system for the upstairs bedrooms, or maybe a ductless head for the master bedroom and a ducted system serving the rest of the house. Modular designs like this give you the flexibility to tailor the system to the home's unique needs and layout. The key is to think about the home's layout, comfort requirements, and efficiency goals when choosing the right zonal system. Choosing the right heat pump for a multi-zone or multi-split design can feel a bit overwhelming, but understanding the difference between these systems can make the process much easier. If you're looking for more details on various zoning and distribution system options, there's a great resource available at cleanheatconnect.ny.gov. You can also check out the PDF guide linked here for a closer look at system options and tips to help you make the best choice for your project. Here's a common scenario. The primary bedroom is calling for heat, but the other zones aren't. In this case, the system could easily short cycle, constantly turning on and off, which impacts efficiency and comfort. To avoid this, consider using multiple one-to-one mini-split systems instead of a multi-split design. This approach can help prevent short cycling and improve overall system performance. From a design perspective, it's best to limit multi-split system to a maximum of 3 indoor zones per outdoor unit. When only one zone is active, it's also important to confirm the system's zonal turndown ratio and minimum capacity. Choosing outdoor systems with better turndown can help a lot with efficiency when demand is low. Keep in mind that short cycling doesn't just affect heating, it can also impact humidity control during the cooling season. If the system cycles too quickly, it may struggle to maintain proper humidity levels. If the system is zoned properly, fewer zones can significantly reduce the customer's upfront and operating costs while making the system more comfortable and flexible. This can make a contractor's proposal more competitive. Proper design and right sizing are key to avoiding these issues and ensuring consistent comfort year-round. All right, so this graph shows how a modulating heat pump's capacity changes with outdoor temperature. You can see as the outdoor temperature drops, the system's modulating zone shrinks. Overlaid on the top are 2 lines. The first is the whole home system. That's the total heat the home needs as it gets colder outside. The second line is the zonal load line. That's the load for one specific part of the house, like the upstairs or the living room. When we use whole home system, we have to make sure that the heat pump's maximum capacity covers the entire load at design temperature. But if we split the home into zones and do it thoughtfully, each zone only needs a fraction of the capacity. We can break that same load into smaller systems that operate closer to their ideal modulation range. Maybe a 18K system for the living room, 2 9K for the bedrooms instead of one big system. The beauty is, those zones rarely all peak at the same time. Heat transfers between rooms, doors open and close, sunlight warms certain spaces. All of that reduces the combined load at any given time. So with thoughtful zoning, the total capacity we need across the home can go down. The problem comes when we overzone, when we start adding heads or ducted zones for every little space. Each zone becomes so small that the equipment can't ramp down low enough to match its load. The heads short cycle, efficiency tanks, and homeowners notice uneven comfort. So the takeaway here is this. Proper zoning allows us to use smaller, right-sized systems that better match real-world conditions. But overzoning leads to oversized equipment and poor performance. The graph helps show that balance, how each zone's load interacts with system capacity across temperatures. Here's a simple example that really shows what is meant by zonal design done right versus zoning that goes too far. On the left is a home that is correctly zoned. It's a single-family, 2-story house in Saratoga County. Design temperature is around 1 degree Fahrenheit, and we're using equipment that's listed in the NEAP air source heat pump product list. You can see the living room and kitchen grouped together. The reasoning here wasn't just convenience or usage, it really came down to thermal conductivity and load balancing. Those rooms share walls and doorways, so heat naturally transfers between them. By grouping these spaces together, we hit this kind of sweet spot. The system serving each zone is big enough to stay within its modulating range, but not so large that it's constantly cycling on and off. Now, compare that to the house on the right. It's the same layout, but we've overzoned it. Now, every small space has its own indoor unit, totaling 6 zones. And that's where the problem starts. Rooms like the bathroom or laundry room have such small loads that even the smallest available head unit is way too powerful. Once you break the house into too many zones, the equipment ends up oversized almost by default. As you can see, zoning is about balance, keeping in mind usage, thermal conductivity, and sizing are critical when correctly zoning. And on this slide, we can see the impact of those two zoning choices. This table breaks down performance for the 6-zone system we just looked at. Each row represents one of those zones: living room, kitchen, bedroom, dining room, bathroom, laundry room. And you can see how their loads compare to the equipment capabilities. The first thing that jumps out is the percent design load served column. Look at zones 2, 5, and 6, the bathroom and laundry. Those are sitting at 324% and 721%. That means those systems are more than 3 to 7 times larger than the actual heating load of those spaces. When that happens, the system can't modulate low enough to match the small load. It ends up short cycling, and that kills both efficiency and comfort. You can also see that in percent annual heating load modulating column, zones 2 and 5 spend the majority of their runtime cycling instead of modulating smoothly. So even though we're using quality cold climate heat pumps, the overzoning design forces them to perform poorly. When you overzone, you get oversized equipment, poor performance, more callbacks, and unhappy customers. The smart approach is to zone by how people live and how loads interact, not by how many rooms there are. If you're looking for more details on how to prevent overzoning, there's a great resource available at cleanheatconnect.ny.gov for a closer look at system options and tips to help you make the best choice for your project. A link to the PDF will be available in the description. Thanks for diving in with us on overzoning. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.